morning, everybody. Video number 8, electron configurations in general. We are going to get into regular electron configurations and excited electron configurations now, based on what we just learned about what an excited electron even is. So electrons are, of course, able to move around orbitals. So when they're given enough energy, they can move and then they return to ground state almost instantaneously. So just throwing that in there, kind of left over from last video to bring us to this whole difference between ground state. So ground state follows the periodic table perfectly. Notice the electron configuration is the bottom on the tile, and it generally goes in a 2-8-8 fashion. So if I look at argon, the 2-8-8 is the electron configuration. That's labeled in the key, by the way. It says electron configuration there. But this is the information it doesn't give you. It tells me that there's 2 electrons in the first energy level, because that would be the first number. Then there's 8 electrons in the second energy level. And then there's 8 electrons in the third energy level. Now, there's some rules to how we fill these, and we don't teach SPDF orbitals anymore or diagonal filling rules. Those are places where you can go for a little bit more explanation, okay? But it goes simply like this. I can't put electrons into that second energy level until I have 2 in the first energy level. So if I were to add these, there's 10, 18 electrons, I'd have to put the first 2 in the first energy level, okay? And then the next rule says I can't put electrons into that third energy level until I get to 8 in the second. I have to be full before I can go into the next energy level. So as long as you know that each energy level needs to be full before you can move on to the next, and you know now that it goes 2-8-8, we're all set. Any deviation now is an excited state. So if I break those rules and then I hence can't find it on the periodic table, it is excited. So here's an example. In this case, I have 2, 7, 8. I can figure out what element that is by adding up all the electrons, because here's one of the big keys. We haven't done the ions yet, but electron configurations, or we did do ions. Electron configurations are not ions. Break that back. Bring this back. We're dealing with atoms, not ions. So the total number of electrons needs to equal what it did before. I haven't gained or lost any electrons. Better statement, okay? So here I see 2, 7, 8. Well, the 7 is a problem. It should have been an 8. I shouldn't have put any electrons in that third shell, for me, which is this way. For you, it's probably this way. I shouldn't have put any electrons in the third shell before I filled up that second shell. So let's do some examples and we'll see what we're talking about. So I see 2, 8, 7, 3. Let me grab my handy dandy reference table. I'll need one of those. And I know I'm not going to find that on here. You can search and search and search, but I know because there's a 7 before the 3 that this is a problem and it's excited. But it does ask me which element, and then am I excited or ground? So here we go. So I'm going to add these up real quick. 2 and 8 is 10, 7 and 3 is 10, 10 and 10 is 20. So I go to 20 electrons, boom, calcium. So this is calcium. And it is excited. And why? Well, this 7, there's a 7 before the 3. There's a 7 before the 3. That 7 should be an 8. And if I look it up here, calcium is 2882. Notice this is a deviation. Same number of electrons, deviation. Okay? So we're going to use total numbers of electrons and prove it's there or not. 2, 7, 8, 5. Add them up. I got 9. 2 and 8 is 10. 7 and 5 is 12. 10 and 12 is 22. 22 is Ti. And Ti should be 2, 8, 10, 2. Is that right? Yeah. And here's the problem. That's 7. That 7 should be an 8. I don't want to confuse you with the 10 because I didn't teach you about the 10. 10 is really not part of this course. We definitely do not get into F orbitals. How about 7 before 8? And this is definitely exciting. You will find as I get farther and farther down the periodic table, there's more and more electrons to be had, which means I have more and more problems. We're not going to get into those too much. We'll stick with these guys here. 2, 8, 6. 2 and 8 is 10, plus 6 is 16. Element 16 is S sulfur. Okay, and it has a 2, 8, 6 electron configuration, so this is ground. And notice I got the 8 first. I got 8 in there before the 6, so we're good there. All right, next one, 2, 5, that's 7 electrons. 7 total electrons is nitrogen. And this is going to be ground. I don't have anybody up in that third energy level before the second energy level is filled. So why this matches perfect. We can say it matches. We could do that for the, that's why I wrote the other electron configuration, because technically it matches. It matches what we call the periodic table. Okay, 2, 6, 7, 2 and 6 is 8, plus 7 is 15. Element 15 is phosphorus. And phosphorus has an electron configuration of 2, 8, 5. And notice it does not match. I jumped 2 up. 2 electrons jumped up on this one, so this is excited. That 7 should definitely be a 5. I should put 2 electrons back down to make it 8 in the second energy level, following those filling rules. Okay, 1, 8, 7. 8 and 7 is 15, and 1 is 16. Element 16, again, is sulfur. And sulfur's electron configuration is 2, 8, 6. In this case, I took 1 from the first energy level and jumped it all the way up 2 spaces. So this is excited. And with that, we just figured out how to tell if an atom or electron configuration is excited or ground. We need to know the filling rules: 2 in the first, 8 in the second, and 8 in the third, and they have to go in that order. If I go out of order, I've obviously excited electrons and got them all mixed up. So with that, we're done.